the very first light created by man. It soon became the focal point of life and generated a comforting sense of safety and security. The light bulb turned night into day and became synonymous with progress. Now there's a completely new type of light that opens up a new dimension. These surfaces light up all by themselves, without the need for fire, bulbs, or LEDs. They create no glare, just a sense of well-being. All points on the object are equally bright, no matter what angle they're viewed from. The secret behind this is electroluminescent coatings, manufactured using a screen printing process. They're made here at Functional Films, a new business unit of Bayer Material Science.
It's not like the light of a lamp in the conventional sense, but more like a glow emanating from within. Depending on the color, completely different moods can be observed and created. The ambiance of a room can be varied in many different ways. Many people even feel that this light has a mystical, mysterious quality.
Electroluminescent light helps to create a mood. It helps us to relax, lifts our spirits, and enables us to tap into our creative side. A new style of living, thanks to a long-established area of physics.
The principle of electroluminescence was discovered in Paris in 1936 by the French physicist Destriaux, by accident. What he actually wanted to do was find out how a metal compound with zinc sulfide could conduct electricity.
Working in his Paris laboratory, Destriaux created strong electrical fields near the metal, and then suddenly it lit up. The reason for this was that the zinc sulfide was contaminated with copper.
When Destriaux witnessed that first electroluminescent light, he could certainly never have imagined the consequences this discovery would have, or what we would be able to do with it 70 years later.
This is a detailed image of what a luminescent surface from Functional Films at Bayer looks like today. Two coatings of electrically conductive plastic form a pair of electrodes, similar to those in a plate capacitor. Between these coatings is zinc sulfide that, as in Destriaux's experiment, contains metallic additives such as copper. When an AC voltage is applied, an electrical field is created. This causes the metal additives to become electrically charged. At their tips, they discharge in a series of flashes, and that's what creates electroluminescent light. At an AC voltage of 110 volts at 400 Hz, this technology generates 16 flashes of light per second. The human eye perceives these flashes as a pleasant glow.
In order to ensure that this luminescent coating functions everywhere, it has to be flexible and elastic. Bayer has succeeded in achieving this. This breakthrough opens up a large number of new potential applications.
The plastic luminescent layer from Bayer has rubber-like properties. It can be applied to angular, uneven, and soft substrates. At Functional Films, the luminescent layer is usually printed on a plastic substrate. This is then molded into the required shape. This means a tried and tested industrial process can be used to add decoration to high-quality objects. To this end, the sensitive films are processed using a newly developed compressed air method known as high-pressure forming. This operates at a pressure 300 times that of atmospheric pressure.
Our luminescent films weigh very little and are very thin. That means we can bend the light around corners and edges, and thus create surface lighting in areas where this was previously not possible.
The first prototypes for industrial applications have already been developed. Take this study of a car of the future from the company Rinspeed. The trim panels glow in a range of different colors. In this instance, the initial prototypes include luminescent elements in an interior door panel. Electroluminescent lighting allows furniture to transcend its purely functional role and to create a specific ambience. In the world of advertising, the content of a poster can be accentuated using electroluminescent lighting. New product innovations are still subject to a confidentiality clause. Nevertheless, one thing is clear: this development heralds a new chapter in the story of light.